This lesson is going to deal with trig applications, so kind of like real world situations. Let's jump into an example here. We have a voltage used by households can be modeled by a sine function. The maximum voltage is 120 volts, and there are 60 cycles every second. What equation best represents the value of the voltage as it flows through electrical wires where T is the time in seconds? Okay. A few things here. Some important information is that the maximum voltage is 120. And then this is really important too. There are 60 cycles every second. 60 cycles every second, that's kind of like indirectly telling us what the period is, right? A period is one cycle. Well, this is 60 cycles every second. We can almost think about this as a proportion. If there are 60 cycles every 1 second, if we want to figure out the period, that's really just one cycle. How long does it take for one cycle to complete? Well, it's 1/60th of a second, but if you need to, you could cross multiply. 1 equals 60x, so x has to equal 1/60th of a second. That's the period. But remember, in our equation, the number that's right here, that stands for the frequency. So we have the period. If we have the period, we can get the frequency, because the formula for the period is 2 pi divided by frequency. Well, we have the period. It's 1/60th. Well, that has to equal 2 pi divided by, make it x again. Cross multiply, we have x equals 120 pi. So that is our frequency. Going to wind up being choice 4. Let's look at a graphing question. You're riding a Ferris wheel that turns for 160 seconds. Your height h in feet above the ground at any time can be modeled by the equation h equals 85 sine pi over 40 t minus 20 plus 90. We want to graph this function. We have a lot going on here. We have a vertical shift, which is really just our midline. We also have a phase shift, or a left and right shift. So we're going to the right 20. So a few things going here. Let's grab all that important information. So we have our amplitude. Amplitude is the value right here. Amplitude is 85. We'll get our frequency. Frequency is right here. So frequency is pi over 40. Let's figure out the period. Period is going to be 2 pi divided by frequency. So 2 pi divided by pi over 40. You can use your calculator for that, but it's going to wind up being 80. So what that means is that it takes 80 seconds for one cycle. So one rotation of this Ferris wheel is going to take 80 seconds. Next, let's go ahead and grab our critical intervals. So critical intervals, that's going to be period divided by 4. So period divided by 4, 80 divided by 4 is 20. That's just going to help us make our x-axis. That's going to tell us when we want to plot points. So we're going to plot points every 20 seconds. Now we're going to graph for 160 seconds, because it tells us in the very beginning that the Ferris wheel turns for 160 seconds. So let's go ahead and grab all of our critical points. So we're starting at 0. We're going up intervals of 20 seconds. So 0, 20, 40, 60, and so on. Okay, so that's our x-axis. Our y-axis, let's see. Our y-axis depends on our amplitude. The amplitude is 85, so if there was absolutely no shift at all, it would go from negative 85 to positive 85. But there is a shift, and it makes sense that there's a shift because we're not going to be negative 85 feet below the ground if you're riding a Ferris wheel. We're shifting up 90. So all of these points move up 90. So it's really going from 5 feet to 175 feet. Now the reason why we're not starting at 0 is if we think of a Ferris wheel, there's some sort of base. Right? You're not going to touch the ground. There's some sort of base we have. And then there's the Ferris wheel. All right, so we have really everything we need. We have our y scale, and we have our x scale. So we're really good to now go on and go to our graph and sketch this. Let me just make this a little smaller. Okay, I'll get rid of this. So let's go ahead and make our axes. And the reason why I'm left aligning it is we're not going to go negative time in seconds. So I'll do the x-axis first. I'm going to skip 2 boxes, I think. This would be 20, 40, 20, 140, and 160. It's probably a good idea to label this as well. So this here is time, and time in seconds. Now our y-axis. We said the y-axis is going to be from 5 to 175. So it's kind of up to you how you want to do this. I think I'm going to skip, I'm going to make every 2 boxes 10. And I'm going to hope that works. 30, 40, 50, 60, 70, 80, 90. Nope, doesn't work. So it's always a good idea to maybe plan it out beforehand. So, you know what, I'm going to make every 2 boxes 20. 60. So that's good. That takes, I only need to go up to 175, so that's perfect. And this is going to be height, and I can't really draw right backwards. Oh, this is upside down, and it's terrible. That's going to be height, and height in feet. Okay. The next thing that I'm going to do is label my minimum value, which is 5, and label my maximum value, which is 175. So 175 is here, my minimum is right here, and my midline, what was our midline? Midline was 90, so I'm going to label that as well. Here's 90. So these red marks, this is the only place where we should be plotting any sort of points, is at 175, 90, or 5. I'm going to draw in the midline. Okay. We're ready to go. We can now plot all of our points. So let's just see, is it a positive or a negative cosine graph? It's a sine graph. Oh, one thing we have to do is shift this to the right 20. So our starting point is not going to be at the origin. It's going to be shifted to the right 20. So I'm going to actually do this as well. Think of this as your new origin, your new starting point. Okay? Reason why I did that was because it tells me that I'm really shifting to the right 20. It's a sine graph. So with the sine graph, I'm going to start at the midline. So here's my first point. And now I'm just going to follow the pattern of sine. So it's up to the max, to the min, to the midline, to the minimum, back to the midline, up to the maximum, midline, and the minimum. Okay, since we shifted to the right, I'm going to have to backtrack a bit. So if I graph this, try your best to make it curved. I need to backtrack. One logical thing would be to the minimum here. And then I'll connect it that way. And that would be our equation. We can label it. And that would be sketching the Ferris wheel. So then we can answer some of the questions. How many cycles does the Ferris wheel make in 160 seconds? Well, here we knew what the period was. It was 80 seconds for one cycle. So if it's 80 seconds for one cycle, it has to be 160 seconds for two cycles. And we could look at it graphically. We can see that. Now if we look at it from here, it's a cosine curve, but here's 1 and there's 2. Okay. And last question, what are the maximum and the minimum heights? We already did that with our important information. The maximum was 175 feet. The minimum we said was 5 feet. Okay. And that's graphing an application question that pretty much has everything. It has phase shift, vertical shift, it's probably the hardest type of question you'll see, graphing, because it has everything.